Today, we are going to study the DWDM principles. In this lesson, we are going to study WDM overview, optical fiber transmission character, key technologies of WDM, DWDM working wavelengths. Now, let's go to see the first content, WDM overview. These slides tell you that WDM definition and relationship with other services. The WDM, for wavelength division multiplexing technology, is a fiber communication technology transmitting multiple optical carrier with information on one fiber. The DWDM carried different kind of services into an open optical interface. That means we can use the DWDM to transmit nearly any service as we can. In the system, we use the OMU to multiplex the different services with a different color and send them to one fiber. In the receiving end, the combined signal will be demultiplexed to each lambda one by one. In the line, we can use a different OA, optical amplifier, to amplify the optical signal directly in order to make the signal reach the further distance. This is a feature of the DWDM. When we use the DWDM, the OA can amplify the optical signal directly. In order to reach the longer distance, it's not necessary for us to regenerate each lambda separately. The cost of fiber is dropped. The DWDM can achieve this following function. Large transparent transmission capacity greatly saves the fiber resource. Each wavelength can carry different signal, SCH 2.5 Gbps, 10 Gbps, ATM, IP, or extra service. Through super long distance transmission technologies, the transmission cost is reduced. WDM is classified into two types. One is CWDM for cross wavelength division multiplexing. Second one is a DWDM for dense wavelength division multiplexing. This diagram shows you that what's the difference between the CWDM and DWDM. In the CWDM, the gap between the two lambda is about 20 nanometer. But in the DWDM, the gap between the two lambda is 0.4 or 0.8 nanometer. So in the DWDM, the band he's using is much more smaller than the band is using in the CWDM. This is also why the DWDM can carry more traffic than the CWDM. By the way, our OA can only amplify the signal running in the C band or L band. So in the DWDM, we can use an optical amplifier, but in the CWDM, we cannot use an optical amplifier. This is also why DWDM can reach the longer distance than CWDM without electrical regeneration. This is the basic principle of DWDM system. One DWDM system is mainly composed of 4 functional modules. One is OTO. OTO for optical transponder unit. There are 2 types of OTO. OTOT, working for the transmitting end, and OTOR, working for the receiving end. The function of OTO is wavelength conversion. In the transmitting end, the OTOT can convert a non-specified wavelength to a specified wavelength. But in the receiving end, the OTUR convert a specified wavelength to a non-specified wavelength. We know that the light is quite stable. It's quite difficult for us to change the wavelength directly. So in the OTU, the optical signal should be converted to the electrical signal. And then we use the electrical current to regenerate a new optical signal and send it to the line. In the OTUR, the received optical signal is also should be converted to an electrical signal, and then the electrical current is used to generate a new optical signal and send it to the clients. Number 2 is OMU and ODU for multiplexing and demultiplexing. OMU is a design in the transmitting end, while OMU can multiplex several lambdas into one fiber. In the ODU, he just executes the reverse processing. The input signal is a multiplex signal. The ODU can demultiplex them into each fiber independently. The third functional module is OA for optical amplifier. We can use a different type of OA in the system. For example, in the transmitting end, we can use OBA. OBA, B for booster. In the receiving end, we can use OPA, P for pre. But in the line, we can use OLA, L for line. So the different OA has a different requirement. The OBA requires high output power to the fiber. OPA has low receiving sensitivity, and the OLA should consider both of them. The last one is a supervision channel. There are two kinds of supervision channel. One is electrical supervision channel. The second one is OSC, optical supervision channel. The most popular supervision channel we are using is OSC. The OSC is generated by the OSC card in one station and is multiplexed by a special multiplexer. So this multiplexer can multiplex both of the signal from the